Good morning, dear students. Uh, I hope you all are well and enjoying this lecture series. So yes, we already done with the introduction of chemical bonding, right? So now I will be starting the theory now that is called valence bond theory. Before I will start, I explain some questions, right? Why VBT is existence, right? કે વેલેન્સ બોન્ડ થિયરી ની એવી રીતે શું જરૂર પડી આપણે, right? So valence bond theory first discovered by Hitler and London in 1927. But why VBT comes to existence? VBT ની શું જરૂર પડી? તો કે first one is I have already told you the about of Lewis theory, right? But Lewis theory failed to explain formation of covalent bond. એટલે કે અમુક કમ્પાઉન્ડ એવા છે કે જેમાં લुईस થિયરી કામ નથી કરતી, બરાબર? તો એમાં કોવેલેન્ટ બોન્ડ કેવી રીતે ફોર્મ થાય છે એ એનું કંઈ મતલબ એમાં કોઈ કામ નહીં આવતી. So Lewis theory does not explain the molecules have also bond dissociation enthalpy and some bond length, right? So Lewis theory failed to explain the shape of molecules, right? Lewis concept આપણને shape of molecules નથી આપતો કે these molecules are in this shape, right? So and also we have another one theory that is called VSEPR theory, but VSEPR theory gives geometrical of simple molecules could not explain. To overcome these limitations, valence bond theory was introduced. આ બધી પ્રોબ્લેમને ઓવરકમ કરવા માટે કઈ થિયરીની જરૂર પડી? તો કે valence bond theory, right? Now what is that theory? So what is valence bond theory? It is also called VBT theory. VBT is used to describe an atom electronic structure. એટલે કે આપણને એટમનું ઇલેક્ટ્રોનિક સ્ટ્રક્ચર શું કરે છે? ડિસ્ક્રાઇબ કરે છે. It is said that the electron fill the atomic orbital of an atom with a molecule and nucleus of one atom is attracted to the electrons to another atom. So it is called valence bond theory. These are the table contexts which we have to discuss in this lecture. First, history of valence bond theory. Secondly, postulate of valence bond theory. Thirdly, number of orbitals and type of hybridizations. Another one is application of valence bond theory, and what are the limitation of valence bond theory, right? So these 5 concepts you have to learn in this video. So first we will discuss about the history of valence bond theory. So as I told you, the Lewis approach to chemical bonding failed to shed the light on the formation of chemical bonds. Also, I have also told you valence shell electron pair repulsion theory, or you can say VSEPR theory, had limited applications, right? And also failed to predicting the geometry corresponding to a complex molecules, right? એટલે કે geometry that means in a shape, એનો shape કેવો છે, right? એ complex molecule છે તો VSEPR theory દ્વારા આપણને એનું કોઈ ખબર ના પડે, right? That's why discovered the valence bond theory Hitler and London. In order to address this issue, એટલે કે આ issue ને overcome કરવા, the valence bond theory was put forth of the German physicist Hitler and London in 1927. The Schrödinger wave equation was also used to explain the formation of covalent bond between two hydrogen atoms. And the chemical bonding of two hydrogen atom as per the valence bond theory is illustrated below. એટલે કે શ્રોડિંજરે બી વેવ ઇક્વેશન છે એનો બી યુઝ થયો to explain the covalent bond between hydrogen atom, right? But valence bond theory કઈ રીતે કામ કરશે એ હવે આપણે જોશું. What are these theories? So we have a H2 molecules, right? In H2 molecules you have a one H and another H, and this electronic configuration is 1s2, right? So આની પાસે એક ઇલેક્ટ્રોન છે and આની પાસે બી કેવો છે એક ઇલેક્ટ્રોન છે, બરાબર? તો આ બંને કેવા છે? હાફ ફિલ્ડ છે. હાફ ફિલ્ડ એટલે કે અનપેર્ડ ઇલેક્ટ્રોન. પેરમાં હોય તો શું કહેવાય? બે ઇલેક્ટ્રોન હોય તો એને આપણે શું કહીએ? પેરિંગમાં ઇલેક્ટ્રોન છે, બરાબર? એક એક ઇલેક્ટ્રોન હોય તો શું કહેવાય? Unpaired electron. So these two unpaired electrons have also some force of attractions, right? These two electrons pair and gives the bond between this, like this. You can see, right? પોતાના બે electrons share કરી અને કયો bond બનાવશે? Covalent bond, and also called a sigma bond. Now, what are the postulates of valence bond theory? So, first one, covalent bonds are formed when two valence orbital, એટલે કે two half-filled orbital belonging to different atoms and overlap on each other. હમણાં આપણે overlapping જોયું, બરાબર? હાઇડ્રોજનનું one has one electron and another one has one electron, right? એ બે ઇલેક્ટ્રોન પોતાના શેર કરી અને ઓવરલેપ કરી અને covalent bond બનાવશે, as you know. And the electron density in the area between two bonding atoms increases as a result this overlapping, right? Thereby increasing the stability of the resulting molecules. The presence of many unpaired electrons in the valence shell of an atom, it form a multiple bonds with another atom, right? It establishes a multiple bonds. And the paired electron present in the valence shell do not take a participant in the formation of chemical bond as per the valence bond theory, right? So what are the first postulate? એટલે કે valence bond theory પાસે unpaired electron હોવા જરૂરી છે. if કોઈ એટમ પાસે pairing માં electrons છે, બરાબર? તો એ bond બનવામાં ભાગ નહીં લે, કારણ કે bond બનવા માટે it have a valence electron, right? It have an unpaired valence electron. Covalent chemical bonds are directional and are also parallel to the region of corresponding to the atomic orbitals and are overlapping. એટલે કે covalent bond કેવું છે? Directional છે, right? Now move on. Sigma bond and pi bond differ in the pattern that atomic orbital overlap. For example, pi bonds are formed from sidewise overlap, whereas the overlapping along the axis containing the nuclei of the two atoms leads to formation of sigma bonding. I know you all know what is pi bonds and what is sigma bonds, right? So moreover, so the atom participating in the bond formation should have a symmetric valence orbital with almost same energy. એટલે કે જે એટમ છે એ બોન્ડ બનવામાં ભાગ લેતા હોય, પાર્ટિસિપેટ કરતા હોય, એની પાસે શું હોવું જોઈએ? સિમેટ્રિક વેલેન્સ ઓર્બિટલ્સ, almost similar energy, right? એટલે કે વેલેન્સ ઇલેક્ટ્રોન હોવા જોઈએ અને એની એનર્જી કેવી હોવી જોઈએ? તો કે similar. And atoms with unpaired electron tends to combine with another atom which also have unpaired electrons. એટલે કે એટમ કે જેની પાસે unpaired electrons હોય, બરાબર? એ જ combine કરી શકે કોની સાથે? તો કે એટમ્સ એવા હોય કે જે બીજા એટમ એવા હોય કે એની પાસે બી unpaired electrons હોવા જરૂરી છે. ફોર એક્ઝામ્પલ તમે અને હું, બરાબર, તમારી પાસે અનપેડ ઇલેક્ટ્રોન છે તો તમે મારી સાથે બોન્ડ બનાવી શકશો, રાઈટ? અને ઈ બોન્ડ બનવા માટે મારી પાસે બી અનપેડ ઇલેક્ટ્રોન હોવા જરૂરી છે. કે તમારી પાસે અનપેડ ઇલેક્ટ્રોન છે અને મારી પાસે પેરિંગમાં ઇલેક્ટ્રોન છે તો અહીંયા બોન્ડ બનશે નહીં, રાઈટ? સો એટમ with unpaired electron tends to combine with another atom which have also unpaired electron, and in this way the unpaired electrons are pair up. એટલે કે આવી રીતે બે unpaired electron ભેગા મળી અને શું બનાવશે? એક pairing બનાવશે, right? And two electrons set between two atoms and constitute a bond, અને bond બનશે. Now third, the number of bonds formed by an atom is usually the same as the number of unpaired electrons in the ground state. So however, in some cases the atom may form more bonds than this, and this occurs by extension of the atom, right? For example, providing it with energy. For example, when electrons which were paired in the ground state are unpaired and promoted into suitable empty orbital, એટલે કે એનર્જી મળે ત્યારે જ bond formation થશે, right? And this increase the number of unpaired electrons and hence the number of bonds which can be formed. In addition to in covalent bond results from the pairing of electrons, right? You all know that covalent bond કેવી રીતે બને? તો કે sharing or pairing of electrons, and these spins of two electrons must be opposite because of the Pauli's exclusive principle, right? You remember Pauli's Hofbauer and Ohm's rule? તો એ બેની સ્પિન કેવી હશે? Electrons ની must be opposite, right? So these are the also postulate કે covalent bond બનવા માટે એની spin બી electron ની કેવી હોવી જોઈએ? Opposite. Also, atoms do not lose their identity even after the formation of the molecules, right? કે H2 molecule છે H atom છે એ bond બનવામાં ભાગ લે તો કોઈ બીજો molecule નહીં બની જાય, right? એ હાઇડ્રોજન જ રહેશે, તો એની identity lose કરશે નહીં, even the formation of molecules. After bond formation, bonding electrons are related with the single center only, right? First પેલા unpaired electron હોય તો એને બે ન્યુક્લિય હોય, બે સેન્ટર હોય. For example, H2 molecules, right? તો H2 માં પેલા one hydrogen and one hydrogen, તો એની પાસે કેવા હોય? બે સેન્ટર હોય. બટ હા, bond બની જાય પછી એની પાસે કેવું? only single center only. It means atom retain their individuality in the molecules. This theory uses in the variation theorem to wave mechanics to obtain the symmetric and asymmetric wave functions. For example, psi A and psi B are the wave function of atoms A and B respectively. The total atomic orbital wave function for the molecule is psi AB is equal to psi A into psi B, and the total energy of system is E is equal to EA and EB, right? Moreover, now what are the limitation of valence bond theory? એટલે કે આની limitation શું હોઈ શકે? Now, according to VBT theory, the structure of B2 and O2 molecules are એટલે કે bonding between BB molecule and OO molecules, right? Which indicates that all electrons in the paired state and hence should be diamagnetic. એટલે કે electron pairing માં જોવા મળે તો એને શું કહેવાય? Diamagnetic. If electron unpaired જોવા મળે તો એને શું કહેવાય? Paramagnetic, right? આ તમે યાદ રાખજો. So, according to valence bond theory, right? એટલે કે valence bond theory પ્રમાણે B2 અને O2 નું molecules છે એની પાસે કેવા electrons છે? pairing માં electrons છે. Theoretically, right? Theoretically જોઈએ તો એ બે પાસે કેવા છે? pairing માં electrons છે. pairing માં electrons છે તો એનો nature કેવો છે? diamagnetic છે. But experimentally data have shown that both these molecules have shown both these molecules are paramagnetic, right? VBT is unable to explain the paramagnetic characters of these molecules. એટલે કે valence bond theory paramagnetic character સમજાવી શકતું નથી. Now what is experimentally? Experimentally that means આપણે energy diagram ભણશું. MO theory માં molecular orbital theory માં energy diagram તમે ભણી જ ગયા છો. તમે શું કહેવાય ચિતાર, રાઈટ? એમાં B2 નો હશે, O2 નો હશે, રાઈટ? તો O2 અને B2 નો જે ઇલેક્ટ્રોનિક ડાયાગ્રામ છે એમાં ઇલેક્ટ્રોન્સ છે એ કેવા જોવા મળે છે? અનપેર્ડ, રાઈટ? તો એ કેવો થશે? પેરામેગ્નેટિક. બટ થિયોરિટિકલી એટલે કે વેલેન્સ બોન્ડ થિયરી પ્રમાણે B2 અને O2 પાસે ઇલેક્ટ્રોન્સ કેવા છે? પેરમાં છે, તો એ ડાયામેગ્નેટિક થશે, રાઈટ? બટ એક્સપેરિમેન્ટલી ઇટ ઇઝ અ પેરામેગ્નેટિક. According to VBT, the covalent bonds are obtained by the overlap of pure atomic orbit of the some constituent of the molecules. But the formation of bonds in this way does not explain the observed properties like bond angle, bond length, etc. Many molecules, right? For example, all 4 CH bonds. Here, the example, all 4 CH bonds in CH4 molecules should be an unequal length. એટલે કે એને unequal length હોય છે. But spectroscopy data shown all CH bonds found to be equal length. In case H2O molecules in OH bonds angle should be 90 degree, but actually the bond angle is 105 degree, right? એટલે કે VBT છે does not explain the observed properties. એટલે કે ઓબ્ઝર્વ પ્રોપર્ટી એક્સપ્લેન નથી કરતું કે ભાઈ આનું બોન્ડ એંગલ કેટલું છે અને આનું બોન્ડ એંગલ કેટલું છે, right? Also, VBT involves complicated mathematics to setting the trial wave function to complex molecules are different. The third one is not important, but you have to learn this one and this one, right? So these are the limitations of valence bond theory. Now, moreover, number of orbitals and types of hybridization according to valence bond theory. According to VBT theory, the metal atom or ion under the influence of ligand and can use its like N-1D, NS, NP or NS, NP and d orbitals for which one? Hybridization to yield a set of equivalent orbitals to define the geometry such as octahedral, tetrahedral, square planar and so on. Right? કે શેપ સમજાવવા માટે આપણને જરૂર પડશે કયા શેપ? ઘણા બધા શેપ છે, લિનિયર છે, ઓક્ટાહેડ્રલ છે, ટેટ્રાહેડ્રલ છે, સ્ક્વેર પ્લેનર, સ્ક્વેર પિરામિડલ, so on. These hybrid orbitals are allowed to overlap with ligand orbitals that donate electron pair for bonding. Now, these are the coordination number. These are the types of hybridization and distribution of hybrid orbitals in a shape, right? If we have a coordination number, then shape is sp3, where 3 px, py and pz and 1 s orbital, right? એક s orbital અને 3 p orbital બોન્ડ બનવામાં ભાગ લે તો એને શું કહેવાય? sp3 hybridization. તો ભાઈ એનો શેપ કેવો હોઈ શકે? તો કે ટેટ્રાહેડ્રલ. વાય ટેટ્રાહેડ્રલ? તો કે એનો કોઓર્ડિનેશન નંબર કયો છે? 4 એટલે ટેટ્રા. Now also it is available in dsp2 એટલે કે એક d orbital, એક s અને બે p2 બે p orbital ભાગ બોન્ડ બનવામાં ભાગ લે તો ભી આવો શેપ આપણને મળી શકે, square planar. If we have a 5 coordination number, then sp3d એટલે કે 1s, 3p અને 1d કક્ષક. તો એનો ભાઈ શેપ કેવો હોઈ શકે? Trigonal by pyramidal. If we have also 6, તો એનો શેપ કેવો હોઈ શકે? sp3d2, 1s, 3p અને 2d. તો કેવો હોઈ શકે octahedral. Oct means 6 and also form D2sp3, right? એનો બી શેપ કેવો હોઈ શકે octahedral. So are the types of hybridization according to valence bond theory and in these shapes. We also I will explain you in detail how the hybridization is formed in our next lecture. So now I want to tell you about something that is sigma bond and p-pi bonds. Now what is sigma bond? This type of covalent bond is formed by the end-to-end. Right? You all know end-to-end, like a head-on overlap of the bonding orbital along the internuclear axis. એટલે કે head on overlap થાય એટલે આપણને કયો bond બનવા મળશે sigma bond. This is called a head on overlap or axial overlap. This can be formed by any one of the following types of combinations of atomic orbital, like SS overlapping. એટલે કે SS overlapping માં બી આપણને જોવા મળે. કેવી રીતે? In this case, there is an overlap of two half-filled s orbital along with the internuclear axis. This type of overlapping can be seen in the formation of H2 molecule માં આપણને શું જોવા મળશે sigma bond. તો એમાં કયું overlapping થાય છે તો કે SS overlapping. Two hydrogen atom with a single electron on this their s orbital overlap together to form a hydrogen molecules, right? Like this s orbital and s orbital. This is the SS overlapping. અહીંયા area હોય overlapping, right? અહીંયા મેં બતાવેલું નથી, but here the area cloud of overlap. Another one is sp overlapping. In this case, there is an overlap of half-filled s orbital of one atom and half-filled p orbital of another atom along the internuclear axis. એટલે કે એક s નો unpaired electron અને એક p નો unpaired electron થી આપણને SS overlapping જોવા મળે. And this type of overlapping can be seen in the formation of methane, ammonia and water. For example, 3p કઈ px, py and pz orbital in the carbon atom overlap with the half-filled s orbital of the hydrogen atom. Now pp or p and p overlapping. This type of overlapping takes place between half-filled of p orbitals with another half-filled of p orbital along with the internuclear axis. And this type of overlapping can be seen in the formation of F2 molecules from the fluorine atom. એટલે કે F માં આપણને જોવા મળશે when two fluorine atom each containing unpaired electrons with the opposite spin each other, then the potential energy of system is decreases. The two p orbital overlap each other when they acquire minimum potential energy. એટલે આવી રીતે જોવા મળે આપણને pp orbital નું p and p overlap, right? So these are the three overlapping SS, SP and PNP overlapping of sigma bond. Now what is pi bond? Pi bond કોને કહેવાય? તો કે during the formation of pi bonds, atomic orbital overlap in such a way that their axes remain parallel to each other and perpendicular the internuclear axis. એટલે કે કેવું રહેશે parallel રહેશે અને perpendicular રહેશે. You know, right, what is parallel and what is perpendicular. During pi bond formation, atomic orbitals undergoes sideway overlapping. Side માંથી overlap થશે, which gives the shear type change cloud above the below and internuclear axis. આવી રીતે parallel થશે, બરાબર? p orbitals and p orbitals. This one. આવી રીતે pi bonds આપણને જોવા મળશે. એવું overlapping, sideways overlapping. Now these are all notes I give you here. You have to remember this. All sigma bonds are, sorry, all single bonds are sigma bonds. એટલે કે બધા single bonds કેવા છે? Sigma bond છે. Multiple bonds contain one sigma bond and the rest are pi bonds, right? Like NH, NN વચ્ચે N triple N, right? તો એમાં એક sigma bond હોય અને બીજા કયા હોય? Pi bonds. But all single bonds are also sigma bonds, right? Pi bonds is never formed alone. Pi bonds ક્યારે એકલા form થાય નહીં. First a sigma bond is formed, then the formation of the pi bonds take place. Acceptations. Carbon molecules contain both pi bonds except carbon. Except carbon સિવાય બધામાં પહેલા sigma bond હોય પછી જ pi bond હોય. A sigma bond is always stronger than pi bonds because the extent of overlapping of atomic orbitals along the internuclear axis is greater than sideway overlapping. એટલે કે sigma bond કેવા હોય? Stronger હોય pi bonds કરતા. Electron clouds of sigma bond is symmetrical about the internuclear axis while that of pi bond is unsymmetrical. Free relation about a sigma bond is possible but not in a pi bonds. The less pi bonds are more stable in the compound. The more of the number of pi bonds, the compound is more reactive. એટલે કે pi bond વધારે હોય તો compound કેવો હોય? Reactive હોય. Now difference between sigma bond and pi bonds. Right? I forgot to write here as, but this is the sigma bond and this is the pi bond. So first one is formed by overlapping along the internucleus, but it is formed by the sideway overlapping of the atomic. Second, powerful bonds because of overlapping occurs in a larger extent, but pi bonds less powerful because overlapping occurs in a shorter extent. Third one is, it is the first bond formed during the interaction between the atoms. It can't become the first bond. They are formed later. Sigma bond પહેલો હોય, બીજો pi bond. Sigma bond exists as a single bond. Single bond exists is not possible. Can't form multiple bonds. But pi bonds form multiple. S, p and d orbitals can form this bond. Only p and d orbital can this form. Sigma bond S, p and d orbitals માં જોવા મળશે, but pi bonds S અને p બંનેમાં આપણે જોઈ શકાશે. It describes the shape of molecules. Sigma bond, right? It describes the length of the molecules. The bond is rotationally symmetrically around the internuclear axis. The bond not rotationally symmetrical around the internuclear axis. Present in saturated and unsaturated hydrocarbons, for example sp3. Present only unsaturated hydrocarbon. Tetrahedral shape માં જોવા મળશે, planar માં જોવા મળશે. This is more reactive and this is less reactive, right? So these are the difference between pi bonds and sigma bonds. This is not in your syllabus, but this is for your kind of informations. Now, bond length. What is bond length? The average distance between central of nuclei of bonded atom is called bond length. એટલે કે average distance between કયા કયા center of nucleus, બે atom વચ્ચેના ન્યુક્લિયનું જે distance હોય સેન્ટરનું, તો એને શું કહેવાય? Bond length. It is also denoted by angstrom. 1 angstrom is equal to 10⁻⁻10 meter. In the covalent compound, bond length is the sum of their covalent radii. That means radius. For example, consider an HCl compound. The bond length is RH plus RCl. In the ionic compound, bond length is sum of their ionic radii, right? Now, bond angle. What is bond angle? The angle between the the angle between the lines represented in the direction of the bond. For example, the orbitals containing the bonding electrons, it is called bond angle. And a right angle, that means 90 degree, 180 degree. These are the angles. Factor affecting the bond angle. Firstly, hybridization. The bond angle depends on the central metal atoms. Hybridizations. Greater the character, greater the bond angle. For sp is 180 degree, sp2 is 120 degree, and sp3 is 109 degree and 28. Secondly, repulsion of lone pair of an electron. The presence of lone pair of electron on the central metal atom affect the bond angle. The lone pair of the central metal atom repulses the bond pair, which decreases the bond angle. For example, bond angle of CH4 is 109 degree, whereas the bond angle in NH4 is 107 because of the presence of lone pair of electrons. એટલે કે lone pair present હોય તો bond angle માં થોડો difference આવી શકે. And electronegativity, the bond angle decreases the electronegativity of the central metal atom. For example, bond angle of NH3 is 107, but the bond angle of PH3 is 93. Right? એટલે કે જો electronegativity decrease થાય તો એનો bond angle બી કેવું થઈ શકે? Decrease. So these are the bond angles. Thank you everyone and have a good day.